Going to look at some angle theorems today. Now, here's the first one. The angle subtended by an arc or a chord, because remember when I say subtend, it's just going from 2 points joining up to a third point. So you could have endpoints of an arc or endpoints of a chord. At the centre is double the angle subtended by the arc or the chord at the circumference. It's better to say arc than chord, and I'll explain why when I put the diagram up. So hang on, here's our diagram. The reason why, remember what I was saying about the angle goes away from the arc? So when we say arc, it's quite obvious which one we're talking about. So if I say arc AC, the angle's going away from the arc. Problem is, when I say chord, a chord's a straight line. So how do I know which side is away from the chord? So it's still correct to say chord, but I tend to prefer to use arc, because then it's more obvious whether I'm talking about the minor arc or the major arc. It's not like we have a minor chord and a major chord. We just have a chord. Okay? So that's my reasoning there, why I tend to go arc rather than chord. So all right, let's actually go and prove this one. If I wanted to use it, that's what I'd write down, angle at the centre, twice the angle at the circumference. But the key piece of information there is on the same arc. Okay? Let's prove it. Okay, going to join in BO, and I'm going to produce it through to a third point, which I've just called X. Now, triangle AOB would be isosceles, because AO and BO are both radii, so they've got to be the same length. So therefore, angle OAB is the same as OBA. Base angles of an isosceles triangle, or how do other people write it? Some people write it the angles opposite equal sides in a triangle are equal. That's how sometimes people write it. Some people just say equal angles in an isosceles triangle. Whatever reasoning you tend to put down for that one, as long as it's correct, of course. Now, AOX is the exterior angle of triangle AOB. So it will equal those two angles added together. But they are the same size. So instead of saying OBA plus OAB, I could say twice OBA. So I now know angle AOX is twice OBA. Well, that was the left-hand side of my line that I drew in. I could have done exactly the same thing on the right-hand side. So similarly, or by similar method, I could say angle COX is twice OBC. And if I add those together, I get the result I'm looking for. So angle AOC must be twice angle ABC. And there's our proof. By the way, in case you're wondering with these proofs, it's highly unlikely you'll be asked to reproduce one of these proofs of the theorems. What the syllabus says is you should see the proofs and know where they come from, but then just be able to use the proofs in a solution. All right, well, leading on from that is the angle in a semicircle is always going to be a right angle. So if I was going to use it, let's draw it. There's my picture. I could say, well, angle ACB, I know that's 90 degrees because it's the angle in the semicircle. And where it comes from, it's quite simple. I just used the theorem we just proved. We know AOB is a diameter. So I can say angle AOB is 180 degrees because it's a straight line or a straight angle. Well, we just said the angle at the centre is twice the angle at the circumference standing on the same arc. So therefore, AOB, which we just said is 180 degrees, is going to be twice ACB. So yes, ACB is 90 degrees. Okay. So that's just the first of our angle theorems. We'll look at some more angle theorems tomorrow, but we'll work on 9b today.